All right, so your focus needs to be high. I would highly encourage you to turn off your notifications and put your phone away and truly focus in 100%. Okay, so if we can tune into this, okay, we're going to do number 5 together in case you didn't do it on your own. And here's how it goes. We have the derivative of a function is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So I have the derivative is equal to the limit as h goes to 0 of what? X plus h to the 5th. Good. Minus x to the 5th all over h. Now, taking x plus h to the 5th power, that's frustrating, isn't it? So I would rather not multiply that out 5 times. Okay? So here's what I would like to do. Now, you don't have to write this, but I'm going to show you how we do it. We did it last year. Here's a reminder to you. If you take a plus b to the 5th, you know it's going to start out with a to the 5th. And then you'll have a to the 4th, and you'll pick up a b. And then you'll have a to the 3rd, and you'll pick up a b squared. Then a squared, you'll pick up a b cubed. And then you'll have a b to the 4th, and it will end with b to the 5th. So what you need to know is that you don't quite have your coefficients, do you? And so we taught you how to come up with the coefficients last year. We used Pascal's triangle. And so what you do is you just add the two numbers that are above it to produce the number below it. So if this is a 1, then 1 plus 2 is 3 and 1. And then 1 and 1 plus 3 is 3 plus 3 is 6, 3 plus 1 is 4, and that's 1. And when the second number matches the degree, that's when you know you're at the right spot. So this is 10, 10, 5, and 1. Okay? So those are my coefficients. Pascal's triangle comes up with them quite quickly for us. So I just do 1 a to the 5th, 5 a to the 4th b, 10 a cubed b squared, 10 a squared b cubed, 5 a b to the 4th, and 1 b to the 5th. So, if you did multiply it out 5 times, awesome, good for you. Don't have to do that. I just use Pascal's triangle. We are going to reference that later on in the lesson. People see how quickly that worked out? Which part don't you understand? The 10? Okay, so I start with a 1, and on the outsides go 1s.
Oh,
and then you just add. So when the second number matches your degree, you're done. Excellent questions. Please, folks, keep asking the question. So the 6 comes from 3 plus 3. 1s are always on the outside. Shh. Folks, we have questions, please. So when the second number matches the degree, you know you're done. Okay? Any other questions how that worked out?
Only the second number.
Second number. Okay, so let's go back to this piece and let's go to work. We have the following. Limit as h goes to 0 of what is x plus h to the 5th, then multiply out to. Plus. Good. We have a 5x to the 4th h. All we're doing is we're just substituting x and h for the a and the b that we had on the previous page. 10x cubed h squared. 10x squared h cubed. 5x h to the fourth. Plus h to the fifth. So that's x plus h raised to the fifth power. Then what? Minus x to the fifth. And that is all over h. Now, what we've talked about is everything that doesn't have an h should cancel. And if you look here, the x to the fifths, those don't have the h, so those cancel. This is extremely important that you see this part. If everything else has an h, true or false, I can divide an h out. True. So you're left with 5x to the fourth, and then a 10x cubed what? H. Because the h divided out, 10x squared h squared, 5x h to the third, h to the fourth. What is h going towards? The limit is h going towards 0. So if h is going to 0, what happens to all of the terms that have an h? So everybody see that those all have an h and they are going to disappear. Because h is going to 0. So if you plug in 0 for h, they are gone. So you do have the derivative of the function is 5x to the fourth.
I get that. So it's like all the a to the fifth, and then like how do you know how to do that?
I need a more specific question. Which part?
Or get rid of the numbers like 5.
Okay, so if we take a and multiply 5 times, you're going to get a to the fifth. Then notice how we reduce 1, and you pick up 1. 4 plus 1 is, yeah.
Okay, I get that.
Oh.
That's it. That's it.
The math is actually let the brain.
I get it.
Yes, you did. Okay, turn in your notes then, so that we can actually do this. Shh, turn to this. We're in section 3.3. Section 3.3 takes a few days to get to. I was originally hoping we could get to a test by next week Friday. It's going to be tough to try to get there, but we'll see where we get. Okay? So, we want to talk about our differentiation formulas. Differentiation formulas, and today I'm going to teach you one you will use for the rest of the year. Literally, it is the most often used thing in calculus. Okay? Can't do this, can't pass the course. Can't pass the test. I mean, we're going to have to punt, folks, okay? So let's look at some general functions. Let's say we have a constant. F of x is equal to a constant, such as, say, y is equal to 8, okay? Suppose y is equal to 8. Somebody describe that line for me. Horizontal line. What is the slope of a horizontal line? So therefore, the derivative of a constant is... So the derivative is 0. So if you see a constant, the derivative is 0. Everybody memorize that? Okay, suppose you have a function y is equal to x. That is a line with a slope of, so therefore the derivative is 1. So f prime of x is going to be 1. Suppose you have a different constant in front. You have y is equal to negative 6x. Again, the derivative tells us the slope. So if it's negative 6x, what is the slope? So therefore, f prime of x is -6.
Oh, so we're actually being like asking to understand like how the term this f prime of 6 from what we're given the problem.
Sure.
It's hard to explain, but
I think we're on the same page.
yeah.
What I want to show you is what happens if we raise x to a power, what we do in that scenario. And so here's how you have it. It says, derive the power rule, otherwise known as the derivative for a function x to the nth power using the formal definition of the derivative. So what I want to do is I want to find the derivative of that. Your focus on Pascal's triangular work is going to make this come alive, and you're going to see how beautiful this really is. I have the derivative f prime of x is equal to the limit as h goes to 0 of, what do I plug in? X plus h. So I therefore have x plus h raised to what power? The nth power minus what? X to the n all over h. We take it step by step. Are you okay with what we have right here? And once again, you guys, I'm not going to just give you the rule. That's the beautiful part of mathematics. We don't make anything up. It comes from itself. No other subject can claim that. And that's what makes math the best. So here we go. It is. But truth is truth. All right. So I'm going to take x plus h to the nth power, and this is going to be the slightly confusing part. The rest is super easy. If I take this, raise it to the nth power, what am I going to start with? X to the nth. Is everybody okay with that? Now, after I have an x to the nth, then I'll have an x to what power? N minus 1, right? So what will happen is when we do this x, so remember Tim said, hey, I don't know what happens with these guys right here. Well, that power gets reduced by 1, right? So we've got n minus 1. And then you pick up an h. And then it will be x to the n minus 2, and you'll pick up an h squared. Everybody see that? And we'll continue to have those until, what will the last one be? H to the nth, and you will have a minus x to the nth. Agreed? Everybody okay with my logic so far? That's all being divided by h. What am I missing right now? Coefficients. Now that's a little bit challenging because we just have a letter up here, don't we? But we do know something to be true. What's going to be the coefficient here? 1. And in front of h to the nth is also going to be 1, agreed? It turned out that the coefficient that went in the second one was the same as the degree, right? Like if I go back here, okay, so we hear somebody seeing that right away. Everybody see how this second coefficient, it always matches there? So what is my degree in this problem? N. So that's going to be the coefficient right there. And it turns out I don't really care at all about the rest of the coefficients, and you're going to find out why in a little while. So I'm just going to put C sub 1 for another coefficient. Okay? So everything else has whatever coefficients, and I frankly don't care about it. We agree, you don't care at this point. Right, we don't care. All right. Because and you'll see why it doesn't matter. So you'll see that part. So this is where you have to chime in. What do you notice? X to the n's cancel. Is everybody okay with that? Everything that's left has an h, so therefore I can divide an h out. So I will limit as h goes to 0 of, and I'm going to divide an h out. If I divide an h out of the first one, what do I get? n times x to the n minus 1. The h is gone. And then what do I have for the next one? C sub 1 times x to the n minus 2 times just h, right? Plus dot, 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 plus h to the n minus 1. So would everybody agree now that the first term doesn't have an h, but everything after that has an h? What is h going towards? So what's going to happen? They're all going to cancel out. Therefore, the derivative, okay, f prime of x is equal to n times x to the n minus 1. It doesn't look like that big of a deal. Folks, the aha moment is going to kick in for you in a second. Are you ready? So look at the n goes here. Okay, so if you have x to the nth, the n just drops in front. And then what happens to the power? It reduces by 1. So watch, folks, what happened here. We just did the problem together. The problem was x to the 5th. So we just dropped the 5 in front, and we reduced the exponent by 1.
But we still have to write all the work out, so it doesn't matter. Yes! So we still have to wait. We still have to write that.
Do you see that?
So, but do we still have to write out all that work? I don't see it.
Shh. Differentiate the following. What shape does that make? What is the derivative of a horizontal line? So f prime of x is equal to 0. Now, does everybody see that the next one is very similar?
Yeah.
Okay, I'm gonna show you it using the power rule. This is negative 8 times x to the 0 power. So our rule says that if f of x is equal to x to the nth power, x to the nth power, then the derivative is this, n times x to the n minus 1. So what you do is you take the 0 and drop it in front. So you get f prime of x is equal to 0 times negative 8x to the, and then we subtract 1 from 0. What's 0 minus 1? Negative 1. But 0 times anything is 0. So we get f prime of x is 0. Now, I don't use the power rule when I see 5 or I see negative 8. I just know the derivative is 0 because the slope is always 0 for that. We agree? Yeah. Now, in this case, you know that the slope is always 4. And so, therefore, the derivative is 4. I'm going to show you why it works. The exponent is 1. So, f prime of x is equal to, you drop the 1 in front, 1 times 4 times x to the what power? 0 power. What is anything to the 0 power, Logan? 1. So you therefore have 1 times 4 times 1, which is 4. And you know by just looking at that the derivative is 4. If you look at letter D, you can add things and the rule still holds true. So I have f prime of x is, what's the derivative of negative 3x? Negative 3. What's the derivative of 5? 0. So the derivative is negative 3. We try letter E, f prime of x. I want to take the derivative of that. That used to take you about 5 minutes to plug in x plus h. All I do now is I take the exponent and drop it in front. What's 2 times 5? So it's 10 times x to the, what's the new power? 1. Because you subtract 1 from 2. Okay, so remember we talked about reducing 1 power? Yeah, that's what's happening. Plus, what's the derivative of 10x? 10. What's the derivative of negative 3? So that's your derivative. It's a beautiful thing, okay? We're going to do these other ones, but just for the sake of understanding, flip to letter K. So this is a problem. Had you had something like this on your previous homework assignment, we would have flipped out, right? Watch how quickly we will take this derivative. I drop the exponent in front, so you get 14x to the 6th minus, drop the exponent in front, you get 18x to the 5th. Drop the exponent in front, 10x to the 4th minus 4x to the 3rd plus 3x squared. Drop the 2 in front to the 6 and we get 12x. And then minus 10. And what's the derivative of that constant? 0. Look at how quickly we were able to take a derivative compared to what we used to have. Not too bad? Okay, so flip back a page and let's go over some of the derivatives that are slightly a little bit more tricky, okay? So what makes letter F maybe slightly more difficult? Yeah, I've got 8x to the 5th, and I've got minus 3x cubed. And here's where everybody kind of says at this point, oh, Mr. Gens, I've already got it figured out. I don't need to tune it at this point. And this is where you make the big mistakes. In order for the power rule to work, you have to have it written in the form of a constant times x to a power. So these two are not written in that form.
So we have to go the long way around?
No, you don't. How do I rewrite 1 over x squared? Anybody? X to the negative 2. If there's an exponent in the denominator, it has a negative value for an exponent. Yes? Okay, and then the square root of x can be rewritten as x to the 1/2. So now you can approach the power rule because it's written in the form of a constant times x to a power. And so there we go. I will say f prime of x is, what's the derivative of 8x to the 5th? 40x to the 4th minus 9x squared. Now let's be careful here. This is where we make mistakes. Let's pause. Okay, I'm going to drop the negative 2 in front. So I get negative 2x to the negative 3. Do you see how some people might write negative 1? If we subtract 1 off of negative 2, we get negative 3. Minus, I drop the 1/2 in front, and it's x to the negative 1/2. So I write it like that. Can I leave negative exponents in my answer? No. So what I want here is a 40x to the 4th, a minus 9x squared. Then what? Minus 2 over x cubed.
Minus the root of x.
Minus 1 over 2 roots of x. So the 2 is from that 2, and then x to the negative 1/2, that's a square root of x in the denominator. Yes. See the 1/2? The 1's in the top, the 2's in the bottom. X to the negative 1/2 means it's a square root of x, but it's in the denominator.
So if it's a negative exponent.
If there's a negative exponent, it goes in the denominator. All right, so here's the mistake that people make. Right here we have f of x is negative 3 over x, or cubed root of x to the 5th. I'm going to rewrite that. That's negative 3 x to what power? Anybody know what power I have? It's the negative 5/3. Okay, negative 5/3.
But you can't have that.
Okay? Now, sometimes people, because they've rewritten it, they think they've taken the derivative. The sign and what you will be communicating to me, and yes, it matters, is you have to then, when you take the derivative, the sign that you've taken a derivative is to put that mark, F prime. That means derivative.
Oh, so just a mark. Just
Yes.
one line.
Now I know you're taking the derivative. Okay, if you don't do that, I think you're rewriting it. I'm taking the derivative. What's negative 5/3 times negative 3? 15/3, which is 5. I subtract 1. What's negative 5/3 minus 1? Negative 8/3. Okay? Can I leave a negative exponent? So I would encourage you, 5 over x to the 8/3. So I got 8/3 because I had to subtract 1, and 1 is 3/3. So if you take 5/3 minus 3/3, there we go. What's that? Well, we took that times that to get the 5. So I had negative 3x to the negative 5/3, and so I'm going to take negative 3 over 1. I'm going to multiply it by negative 5 over 3. And I got 15 over 3, which is 5. Okay. So sometimes people like to try to go back to a radical. You don't need to. And I would encourage you just please leave it as a fractional exponent.
Okay.
Okay? Why did I what?
Why did we go
For the square root. Very common for people to just write square root if it's a 1/2 power. So I'm just trying to do what you're going to see the most as you move forward. Okay. All right. Last two. Letter H. This is written in appropriate form. So I have f prime of x is equal to, what do I do? 6 over 7 times negative 2 over 5. X to the, what is 6/7 minus 1? Negative 1/6? I'm sorry, negative 1/7? Sorry. Okay. So f prime of x is equal to 6 times negative 2 is negative 12 over 35. And does the x to the 1/7 go at the top or the bottom? The bottom. So what sometimes people make a mistake on this problem, do some people understand why they would drop the 12 down to the bottom as well? They do, but there's a difference between a negative value and a negative exponent. Okay? The last one we do today is letter I. And you see a negative times 1 over 3x to the negative 2. This is problematic for a lot of people for a lot of reasons, but I cannot use the power rule yet. I have to rewrite it. So to show I'm rewriting it, I just write f of x, not f prime, and I have a negative, and I'm going to use up this negative in the exponent up here. What do I do with that exponent? Right, so that you understand, does everybody agree that 1 over 3x is the same as x over 3? That this is the same as x over 3? Yeah. So I can use up the negative, that just means I flip it. So this becomes a 3 over x. So I've used up my negative. Are we okay with that? Now I'm going to square everything. I still have not taken a derivative, so I'm not going to write f prime. F of x is equal to negative, and then what is 3 squared? 9 over x squared. I'm still going to rewrite that as negative 9 times x to what power? Negative 2. So again, sometimes people are like, oh, I think I'm done. Have I taken a derivative yet? No. So f prime of x is equal to, I take this and I drop it in front, which gives me 18x to the negative third. I can't leave that, so it's
18 to the x. So 18 over x.
Yeah, and that's my derivative.
Okay. I kind of like this. Not too bad.
I will be honest, folks. Sometimes there's more people that get points off for not doing their power rule correctly, as opposed to people who are doing the f of x plus h incorrectly. So if you open up to your next worksheet, that is all the power rule. Just simply practicing this piece. We will do a checkpoint on it at the beginning of class tomorrow. We want to make sure that you can do 6 problems, that you can do them well, and you can do them quickly. So, good job.